In this video, I'm going to do sample problems from the same worksheet, but I'm going to be solving 6A, 7B. These have to do with density. And then I'll skip to the second page, and these also have to do with density number 10, 13, and 14. So starting with number 1, calculate the density in grams per mil of this solution. Remember that the formula for density is mass over volume. And if I look at the first, or problem number 6, they're asking us to report the density in grams per ml. So gram is my mass amount, volume is in milliliters. When I look at the problem, this one's going to be pretty straightforward because they give us the volume in units of milliliters and they give us the mass in the units of grams. So this one's not going to be too challenging in order to calculate. So starting with 6A, oops, let me find some paper here. Okay, so starting with number 6A on the worksheet, density is equal mass over volume. And according to the handout, what they're reporting to us is that the mass amount is equal to 18.55 grams. And then the volume amount is equal to 25.8 mLs. And so when I do this on my calculator, this is the volume. When I do this on my calculator, the units that I'm going to get are going to be grams per ml because that is what is in my formula. So I've got G over ml, and the number that I get when I do this is approximately 0.7. So there's the answer, is 0.7 grams per ml. So there's a couple of ways, just as kind of a quick aside, there's a couple of ways that you can write this. You can also write this 0.7 G per ml. And so the interpretation of this is that if you have 1 milliliter of this liquid, whatever it is, 1 milliliter of the liquid sample that we're looking at, has a mass of 0.7 grams. Or you can also say that 0.7 grams of that liquid sample occupies a space of 1 milliliter. Okay, so that's what that means. That's what the density means, 0.7 grams per ml. So you can write it like this with the G per ml as a fraction, or you can write the number in front of the G and it's implied that you're talking about 1 ml. Incidentally, when you hear the word per, that means that you're going to have the divide sign. Okay, you're going to have the fraction bar as part of your unit. So this would be 0.7 grams per ml. You pronounce the bar as per, P-E-R. Let's look at number 7B, because this one's got a little bit of an extra step to it. They want the density, so they say to report the density in grams per ml. But here's what they give us, is that the volume is 0.4 liters, and then the mass is 150 grams. There's more than one way to solve this problem, so I'll solve it a couple of different ways. But here's one strategy, and that is to go ahead and convert this directly into what you're going to need it in, directly into liters. Remember, density is going to be mass over volume. And according to the problem, we want this in grams and this in milliliters. But the problem gives it to us in liters. So we can convert that 0.4 liters to mLs first. So 0.4 liters. And using our little chart from last time, remember that chart that looks like this? King Hector died drinking chocolate milk. You can figure out the difference between liters. This would be liters right here. That is a difference of 1,000. So 1,000 milliliters, because it's the smaller unit. 1 liter, that would be 400 mils. So once you do the conversion, now you can calculate the density. And so density is going to be equal to the given mass amount of 150 grams over what we calculated in milliliters. And that is going to give us an answer of 150 divided by 400, 0.375 grams per ml. So that's one strategy, is to convert this first into milliliters. Okay, is to convert that. So that's strategy number one. Strategy number two. Oops, I misspelled strategy both times. There we go. There's an R in there. So strategy number two is to go ahead and calculate the density first. And then do the conversion. So we could have density is equal to 150 grams divided by 0.4 liters. When we do that math, we actually end up with 375 grams per liter. So part two, the second step here, would be to convert 375. Remember how we can write this gram over L? And just to convert the liter part by multiplying, 1 liter is equal to 1,000 mLs. So when you do that, you end up with the same answer, grams per ml. Because if you notice, this and this will cancel, leaving you with the units of grams per ml. So two different ways that you can solve the same problem, but they're both going to require a conversion before you actually calculate the density, because of how the information is given to us as compared to how they want us to report the answer. Let's look at number 10. Number 10 is also a density problem. It says we have a block of lead. So we've got a block with some dimensions. So they've measured that block. Well, I can never draw these right. There we go. Measured the block. I think you guys get the idea, but here's the block. So they've measured this block, and they've measured it to be 4.5 centimeters by 5.2 centimeters. I said 400, didn't I? So 4.5 centimeters by 5.2 centimeters by 6 centimeters. So if we multiply those numbers together, that will give me centimeters times centimeters times centimeters, which is centimeters cubed. So 4.5 times 5.2 times 6, that is 140.4 centimeters cubed. Remember that the volume of something like a rectangle or of a square, it's simply going to be height times depth times width. And that's what we have here, height times width times depth. And so if you remember, 1 cubic centimeter, which is also written like this, is equal to 1 milliliter. So since we have 140.4 cubic centimeters, you could write that as 140.4 milliliters. Oops, I forgot the 0.4 there. So 140.4 cubic centimeters is equal to 140.4 milliliters. And so now for the density, all we need is the mass because we have the volume. And according to the problem, this block of lead has a mass of 1587 grams and a volume of 140.4 mLs. So 1587 divided by 140.4 is equal to 11.3 grams per ml. Now the problem didn't state that it wanted it in grams per ml, so you could have reported the answer as 11.3 grams per cubic centimeter, or you could have also reported it as 11.3 grams per cc. That would be, technically that would be correct because the problem didn't specify. But most of the time, if the problem doesn't specify, usually we report density in grams per ml. Let's look at 13. Uh, 13, it is a density problem, but this is kind of interesting because they give us the mass of a chemical called benzene. So we have a mass of benzene, looks like 250 mils. Then they give us, oh no, this is the volume. I'm sorry, this is the volume of benzene is 250 mils. And they give us the density of benzene at 0.8765 grams per ml. And they want to know what is the mass. Well, we're going to rearrange our density is mass over volume in order to solve for mass. So if volume is down here at the bottom, I can do this. I'll show my steps in case you like to see the steps. So I'm going to multiply both sides by V over 1. That will cancel with this. And I'll end up with dV is equal to M. So the mass is going to be density times volume. So the density is 0.8765 grams per ml times the volume is 250 ml. And watch this, mils and mils will cancel, leaving us with grams, which is the mass unit that we're looking for. So 0.8765 times 250. Looks like it's going to weigh 219.1, I'm going to round that to 3 grams. So a 250 mil sample of benzene will have a mass of 219 grams. I'll write that out for you. So a 250 ml sample of benzene has a mass of 219.13 grams. So this is still a density problem. We're just rearranging the density formula. Last one, number 14. Last one, number 14. problem says, what volume of silver metal, so what volume, will have a mass of exactly 250, or no, 2,500 grams, and the density is equal to 10.5 grams per cubic centimeter. So we're looking at a sample of silver, and we want to know if we have a piece of silver that has that has a mass of 2,500 grams, and this density, how much space will it occupy? So again, we're doing density is equal to mass over volume. So this time we're trying to solve for volume. So if we show our steps here, D is equal to M over V. I'm going to multiply both sides by V over 1. And I'll end up with dV equals M. And I'm still trying to get volume by itself, so now I'm going to divide both sides by density, and I'll end up with V is equal to mass over density. So now I can substitute. I've got 2,500 grams. I'm going to show this as a multiplication problem. 1 over density would be 10.5 grams per cubic centimeter. That's how I would write it if I was showing the steps. And the reason I want to write it out this way is that I can show you that grams and grams will cancel, leaving me with cubic centimeters, which is a reminder that this is another way to write milliliters. So 2,500 divided by 10.5 is equal to, the volume would be 238 mLs. Okay, so the interpretation would be here is that if I have a sample of silver, okay, a sample of silver with a mass of 2,500 grams would occupy 238 mLs of space.